Hello and welcome to our Seawork Insights webinar. I'm Debbie Mason, the editor of the sister publication to Seawork, Maritime Journal. In today's webinar, we're going to hear from two speakers from IMCA, the International Marine Contractors Association, who I'll introduce in a moment. This webinar is a prelude to our main conference at Seawork in Southampton this June, and it's going to look at autonomy, automation and remote control on or under the seas, and where we're at with regulations, guidance and compliance. And don't worry, if you miss any of it, the webinar will be recorded and put on our Seawork website, and our speakers are happy to be contacted afterwards. So, to the speakers. First up is Richard Purser, Technical Advisor, Marine with IMCA. Richard joined IMCA in 2021 following a 25 career in dynamic positioning. He started his career at P&O Containers, gaining his Class 2 engineering certificate before moving into the offshore industry, working on seismic surveys, pipe layers, and then on DSVs, achieving his Class 1 Chief Engineer's certificate. Richard then moved to Trinity House Lighthouse Authority to work on its new build programme before coming ashore with Aberdeen-based DP consultancy, PML. He spent 13 years as a DP practitioner on all types of DP vessels, as well as incident investigations and FMEA analysis on mission-critical equipment, specialising in closed-bus FMEAs using advanced generator protection systems and hybrid battery systems. Please welcome Richard Purser.
Hi. You have the slides, please. Okay, so we're going to look at two pivotal documents that IMCA have produced for the auditing process of USVs and ROCs. And they represent IMCA's proactive response to the rise of uncrewed surface vessels and remote operation centres that command them. Our goal is simple: to provide a base level of knowledge and competence that ensures these technologies operate safely and reliably, as the crewed vessels often working alongside them do, and create a formal global standard of assurance and auditing across the industry. The marine landscape obviously has been changing quite dramatically in the last few years, and this often where we have the issues is where regulations are struggling to match that, because the industry is moving faster than the regulations. We've seen the surge in USVs and ROC operations, yet the IMO mass code is still emerging and won't really be into effect properly until sort of 2030. So this left us with an assurance gap. Our existing IMCA templates were designed for crewed vessels, and they simply weren't suited for the uncrewed operations, where the bridge may be thousands of miles away from the hull. The industry didn't want to wait years for regulatory catch up, and it was clear. I got the clear vocal demand. People were calling me asking if they could use the small boat version of the eCMID, if they could sort of shoehorn it into some sort of assurance process. So what we did is we developed M271 and M272 as a result of that demand. When we talk about the insurance gap, we're talking about risk management essentially, and without standardized framework, operators' clients are effectively making up their own rules, and that lack of consistency creates uncertainty for all stakeholders: insurance, clients, regulators, everybody. So by developing these documents, we aren't just creating checklists, we're creating a bridge between today's emerging tech and tomorrow's formal international code. So we're trying to get ahead of the curve effectively on that. Development was carried out on behalf of the IMCA Mass Committee. We have a dedicated Mass Committee here at IMCA, but we used a small work group outside that committee, and that work group, we can put anybody in. They don't have to be necessarily IMCA members. So we had that small work group consisting of, at this time, industry subject matter experts. We looked at how we could adapt the proven success of the eCMID system to a world without onboard crew, and we focused on splitting the assurance into two distinct areas but linked. and that will be the vessel itself and the environment from which it is controlled, which is the ROC, Remote Operations Center. This approach allows us to be precise. You cannot inspect a USV using the same criteria as the remote operation centers, but you cannot have safe operations without assuring both. And we all know some of these ROCs could control multiple USVs, and a single USV could also be controlled for multiple ROCs. So that's sort of, there's some unique problems associated with this. So we'll look at 271, which focus specifically on the vessel. And this is the physical hardware out at sea. The inspection focuses on the hull, propulsion, sensors, and the energy systems. However, it goes deeper than that, than just the machinery. It confirms that the vessel is a safe system of work in place, has a safe system of work in place, and crucially addresses both cyber and physical security. We also look at emergency and pollution controls. And just because there's no one on board, it doesn't mean to say the risk of to the environment disappears. There's still power plants involved, bilges, and so we have to account for all that. And furthermore, 271 is designed to supplement the other technical standards, whether that's DP, survey equipment, or energy storage systems. So we know that we're going to have to add to this to a certain extent, and I think Roger maybe touch on this, but the vessels are actually going to be doing something. So they're going to have deploying ROVs. They're going to, as they get bigger, they're going to be deploying construction equipment. So their missions will change and get more complex as they develop. Now we turn to 272, the brain of the operation, which is the ROC. This is a significant shift for maritime auditing because we are moving the focus to a shore-based environment. In a ROC, the hardware is only half the story. M272 evaluates the safety management system and HSE culture of the centre. We look at operator competence, ensuring the people at those screens have skills required for remote command. We're also scrutinising the communication links, checking for redundancy, fail-safe functions. If a link goes down, the vessel must be able to look after itself safely. And going back to the operators, at this point, we're sort of assuming marine operators in the traditional sense. This is going to be very much subject to the STCW review carried out by IMO. So there may be changes there, and we still don't fully have a handle on who will qualify as these operators moving forward, because it opens up the industry to a whole different set of people. You may ask why we integrated it into the eCMID system, or we're planning to integrate it into the eCMID system onto that sort of platform. And the answer would be credibility. eCMID is a trusted system with over sort of 1,000 inspections annually already happening. It uses the familiar yes, no, not applicable structure that inspectors and clients already understand, also allowing for free comment in the text boxes. By using our centralized database, we can perform risk trend analysis, and that comes up much in the CMID, where we can see which questions are continually getting a no answer or non-conformity against them, things like entry into enclosed space. So when we pick up on that, it allows IMCA to then do a safety campaign of sorts for that. Most importantly, it uses will use accredited AVIs to ensure independence and high quality reporting. This reduces audit fatigue for operators who would otherwise be facing multiple non-standardized inspections. It also provides a global standards with inspections being conducted annually. So hopefully, once you've had one in a 12-month time, you don't need another one. So where are we now? Well, we released it, the initial version in 2025, sort of end of Q3, Q4. And it's an offline system at the moment. So you can go to our website, you can download it. You don't have to be a member of IMCA to download it. It's in front of the firework. We're after feedback. So we desperately need people to use these documents in order to come back to us and say, that's not right, you need to add this, this isn't quite working. So we desperately need that feedback before we can put it into the full platform. Also, establishing a new AVI accreditation specifically for USVs and rock inspectors, as a skill set required is slightly different from the traditional onboard auditing. Additionally, the document that looks after the EC MID 167 will require update as well to bring in this new emerging technology. So in conclusion, 271 and 272 are about bringing structure and consistency to the sector that has moved very fast and is moving very fast. We know that it's inevitable that vessels are going to get larger and larger and larger, and they're going to be working in the same space as your traditional DP vessels do today. So by adopting these standards now, we're reinforcing credibility of the entire marine contracting industry before more formal regulations are set in stone. So we're telling the industry, look, we're already moving ahead here. And we aren't just presenting the finished document, we're inviting you to trial these documents, provide feedback via the email provided, or any info email to that you can find on IMCA's platform. And we need you to help us shape the future of these two documents. Thank you for your time today, and I'm happy to take any questions you may have at the end of this session. But yeah, please get out there, use them, get your red pen out, criticize them, because without that, we don't know if the documents are working, if they're fit for purpose, and we need that. And then that will allow us to help IMO with the mass code moving forward. So thank you very much.
Thank you so much for that, Richard. Really useful. And to reiterate, if anyone has questions, either go directly to him or put them in the chat box. If you haven't done it yet, please do so, and we will get to them at the end. Next up, we're pleased to welcome Roger Moore, Technical Advisor, Remote Systems and ROV, Offshore Survey and Competence and Training. Roger joined IMCA in July 2023, having spent the previous 27 years working in the ROV industry around the globe, most recently for the James Fisher Group. Over his career, he's held positions offshore from trainee pilot technician to OPM and onshore as an ROV operations manager and technical authority. Prior to this, Roger served in the Royal Electrical and Mechanical Engineers, which gave him a foundation in all manner of mechanical and electrical equipment. Roger has written several training programs and has hosted internships as a STEM ambassador. Please welcome Roger.
Thank you, Debbie. So good morning, everybody. I'm Roger Moore from IMCA, and today I want to talk you through an issue or ongoing discussions, if you like, that we've seen while running several of our specialist work groups. So as Richard has said in his presentation, this is a fast-moving field and regulation is still catching up. So one of our tasks at IMCA, we feel, is to make these issues known so the correct regulation can be written. So my talk today is on automation and autonomy in the marine operations. So this presentation looks at automation and autonomy, specifically why different frameworks such as the IMO or the DMR are often misunderstood, and when they're compared side by side. The focus is on IMCA and mass and offshore operations, where high automation already exists, but it is often poorly described in regulation language. DMR being the Defence Maritime Regulator and the IMO being the International Maritime Organization. So we're going through discussions at present in the AUV work group, for instance, and this has highlighted some talking points. So automation is not a future concept. It's already embedded in DP systems, ROVs, AUVs, and USVs, and regulation is largely catching up rather than leading. This has created confusion between automation versus autonomy, and between the functionality, functional capability versus regulatory classification. And that also can confuse and distort the risk perception, and also undermine the meaningful safety discussions that we're having. The core problem is that different organizations use level of autonomy to describe very different things. So the IMO autonomy levels are high level and they're regulatory, whereas DMR levels are functional and operational. So these two scales often compare directly, even though they are never designed to describe the same thing, if you like. So the IMO developed degrees of autonomy during their mass scoping exercise. The purpose was not to define the system capability, but to assess how existing conventions like SOLAS and COLREGs and STCW, how they apply. The emphasis is on where the human is located and who has control authority, and also whether the vessel is crewed or uncrewed. Just skip on to the next slide, sorry. There we go. The IMO, as you may be aware, defines 4 degrees. So degree 1 covers the automation process with the crew on board. Degree 2 is the remote control with the crew on board. And degree 3 is remote control with no crew on board. Degree 4 is fully autonomous. So these degrees are deliberately broad, and they're intended for regulatory interpretation rather than the engineering detail behind it. So one limitation of the IMO scale is that it doesn't distinguish between the decision support and the execution, and it also doesn't clearly capture the difference between human in the loop and human on the loop control. So as a result, highly automated offshore systems still appear as degree 1, despite significant autonomy at that system level. So to give you a bit of clarification on this, we define human in the loop as a system where a human must explicitly approve or initiate an action before the system can proceed. So for instance, the system may analyze data and propose an action. The execution is gated by a human confirmation. If the human does nothing, then nothing happens. Human in the loop is part of the control loop, so it's not just an oversight. So typical examples of these are an ROV autopilot that computes a maneuver but waits for the operator to confirm it, or a collision avoidance system that recommends a change in course but requires approval. Human on the loop requires is a system where automation executes actions autonomously. So while the human supervises, but also can intervene or can override if needed. So for instance, the system decides and acts on its own. The human monitors the system behavior, interpretation, and is optional, but it's always possible. So typical examples of this are station keeping or DP functions, operating automatically under supervision. Autonomous transit with an operator ready to intervene. ROV functions are automatic unless the limits are exceeded. The last one being human outer loop. So this is the full automation of the course. There's no real-time human safety net with that one. So that's one that the IMO is obviously going to be looking at in great detail. So DMR focuses on describing functional automation capability. So who decides, who executes, and who supervises, and where the humans intervene with that. This is much closer to the automation models used by classes like D&V and Lloyd's, and that does align better with how engineers and operators actually think about the systems. Even us, when we're doing these full inspections and stuff, that's the way we interpret things, as opposed to a regulatory database like the IMO is going for. The DMR style levels range from manual to assisted operation through decision support, so human in the loop, on the loop, or conditional or full autonomy. These levels describe the increase in delegation of the decision-making process and the execution to the system rather than where the human is actually physically located, for example. The key distinction is that IMO is regulated and ship level. It asks, where is the human? DMR is operational and system level and asks who decides, who acts. So both are valid, but they ask a fundamentally different question. So this slide shows an approximate mapping. It's not an equivalence. So manual and decision support typically sits within degree 1. In the loop also remains as 1, on the loop degree 2, without crew degree 3, and full automation degree 4. The key point is that mapping is approximate and it's context dependent. So you've got to ask yourself, well, why does this matter? So ROVs, DPs, AUVs, they already operate at high levels of automation already, and also conditional autonomy. However, vessels supporting these systems remain degree 1 because the crew is still on board. This can create a risk in that the true operational complexity and autonomy of that system is underestimated in the regulatory and the safety discussions that you're having with those. So higher automation does not automatically mean a higher risk or a higher safety level. Safety depends on the context, so how a system is supervised, how failures are managed, and also the competence of the people involved within that. So treating automation, autonomy, and safety as interchangeable concepts, that leads to poor conclusions. The key takeaway from this presentation is simple, that IMO levels of automation describe where the human is for regulatory purposes. DMR levels describe what the system actually does, and confusion arises when only one framework is used. So we have to make sure that you answer the questions for both. IMCA supports IMO mass framework, but cautions against oversimplification. And the emphasis should always be on functional clarity and proportional regulation. Understanding what systems actually do is essential if the regulation is to remain credible and effective. These discussion points are intended to prompt a debate. How should autonomy be described in a safety case? Should the IMO formally recognize functional automation levels as well, which currently they don't do in their plan that they've set out for 26 and 30? And how do we avoid misclassification of an offshore or subsea system as autonomy levels increase? That's it. So thank you for listening.
Thank you, Roger. That's very interesting. And actually, I'd just like to go back to remote operations centres to start with, because we're talking about inspecting them. Well, I was at Oceanology last week in London, and Fugro was giving a sort of seminar, and there was a panel discussion. And they were saying that at the moment, there are certain operators who are literally sitting in their bedrooms operating ROVs. So it sort of ties in quite nicely with the first question. Will inspections of rocks be mandatory, and will they be mandatory for IMCA members, or how does it always all work, and is it trial and feedback at this stage?
Yeah, I was actually on that panel that hosted. Yes, no, it's not mandatory, but it's what the industry wants. So it's what the stakeholders, so the charterer, will want to know that there's a certain standard there. You know, ISM codes, safety management systems. And yes, I do think at the moment there are literally people in their front kitchens operating these very small drone type vessels, but we're talking about the offshore construction industry. And as I said, these things are going to get bigger, so they're going to come under more scrutiny. And once you start putting them in within 500-meter zones of the rigs and putting them in the same space that the traditional DP vessels are now, then there's going to be a certain level of assurance required. Even the P&I clubs will want some sort of level of assurance for insurance. So it's not mandatory, but it will naturally progress that way, I suspect.
Well, it doesn't need to be mandated for somebody to want to protect their asset, I guess.
Yeah, exactly.
Which leads me to another question. Who actually does, if something goes wrong, who takes responsibility? Is it the operator? Is it the developer? Is it who actually takes responsibility?
That goes into contractual sort of
right
realms. I mean, who owns the risk? Everybody really owns a risk, and it's incumbent on everybody to make everything safe. But at the end of the day, whether we like it or not, it boils down to financials. So that's something that I mean, you raise a good point there, because these contracts will become more complex. You know, you probably won't be signing the similar contract for a USV construction vessel as you would for a normal manned DP vessel. So there's so much going on here, and the regulatory framework is lagging behind. We need to be in front of the curve in order to, as you point out, sort of head off what is coming over the horizon and be prepared.
And coming very quickly. Roger, do you have anything to add?
Only that, you know, we've already seen this in, you know, legally wise sort of thing in Brazil, where Fruba and others are operating, and they're actually stipulating that any remote operations, they must have someone on the ground in Brazil, even though the ROC is elsewhere. And this, I think, is purely for the legal aspect, so there's someone that they can arrest if something goes wrong.
Right.
If you're outside of the country, that's not going to happen. You know, so they are putting that into their regulations. The ROC can be everywhere, anywhere they want, but it has to be here. And I don't think the bedroom scenario is ever going to be, you know, expanded in this line of thought, because this is like a highly regulated construction.
Let's hope not.
If you like. So the ROC itself has to be secure. It has to have backup systems. It has to have a lot of things going for it. And if you look at the ROC inspection document that Richard's got there for the USVs, we've got one that also in the ROV documents for ROV control. So when you're looking at vessel control, ROV control, USV, AUVs, which is the next one we're writing, they do go a lot into detail on, you know, who has access to it. And you're looking at the security side of that as well. That's quite a heavy topic at the moment, is, you know, how do you stop access to these for, you know, other purposes?
Yeah. Well, it's such a fledgling, even though it's happening so fast, it is still a fledgling industry. So we have another question in the chat box that says, we see that several of the USVs in operations are mentioned DP equivalent instead of DP classed. Is this still under class considerations to issue DP class certification instead of stating equivalent? And if not, what are the reasons?
Again, it's an interesting, and it's not the first time this has been brought up. I've had discussions with members about this. You know, what is DP? Some of the players will tell you it's a tool. Others will say it's a, you know, it's all incumbent, the vessel, and should be classed. I haven't got a definitive answer for you on that. I have a personal opinion on it, but it's very much sort of in front of the membership and being discussed. Is if a vessel does have DP, it uses it, then should it technically have DP notation if it's using it for its mission? I don't know if that answers the question very well, definitively, but as I say, it's on our radar.
Right. All in work in progress. Another question here, what specific qualifications will an AVI need to inspect a remote operation centre?
Again, that's a new one. We work with IIMS, the international, it just escapes me there, Institute of Marine Surveyors. They provide the training for AVIs, and again, we're in discussion with them is who do we initially grandfather onto the scheme, and then how do we develop a scheme in which AVIs can be trained up to do this, because it is a slightly different mindset. I think a lot of this will come out from the feedback we get on the documents, what's going right, what's going wrong, who's commenting on them. It gives us some sort of gauge of what's required.
And just to add to that as well is, now that we're sort of like linking in the ROC and the AUV side of things, the ROV and AUV side of things, inside that is, or on the back end of that, is the ROV system inspector qualifications that we're now looking at. So whereas with vessels you use AVIs, with the ROVs it's predominantly been ROV supervisors. So we're now, the work groups are now been formed, they're looking at it. There's going to be an experienced practitioner scheme whereby we bring people in, they'll have to sit an exam to be an ROV system inspector, and then there'll be a trainee ROV system inspector process where you can apply and be nominated by your company to be a ROV system inspector, and part of that is the ROC delivery, the inspection of that. So yeah, it's all about competence levels. It's about the person who's inspecting not only must have the competence to be able to do that job, they also have to know the platform that they're actually working with and have a relevant experience behind it to make the client, if you like, accept those inspections.
Yeah, sure. Okay, next up, what about insurance coverage? For example, P&I, wreck removal, oil pollution, and so on. Our questioner says, it seems that this area has not been sufficiently addressed. Additionally, what about the responsibility of the USV pilot for actions that could potentially result in criminal charges, for example, loss of life or significant damage? So if we go for the first one, the first part of that, the insurance coverage.
I don't know if Roger probably has more experience because of the ROV pilotage type side of things to answer this. I don't.
Well, yeah, I mean, it was all covered under the corporate structure within the company who's doing it. So it's based on the contract level. So once you have the contract, you in your tendering process, you'll put that through. It will say ultimately who has control, and they're responsible for making sure that everything's done, and that includes redundancies, in systems and stuff like that. So as far as insurance is concerned, it still sits with that the tender holder.
Right. So a bit of a headache for them as well.
But ultimately, the USVs, even the AUVs, they're looking. That's why this level of automation is being looked at, is because once we get to a higher level of automation, it's like a car on the road. You get these Tesla models or any other ones that are available. If they're operating, who is it that's going to be responsible for any accidents and stuff? So that's what they're looking at on a waterborne environment as well.
Right. And to the second part of that, the responsibility of the USV pilot for potential criminal charges.
I don't know whether that will fall down to the actual pilot itself, because as long as they're competent, he's employed, so he'll be covered by his employer's insurance. I'm sure that's where it'll fall. Yeah. We do have a legal entity at IMCA as well. So if anything specific comes up that you want to discuss, then you can forward it to us, and we'll pass it on to them as well.
Right. Any other thoughts on the sort of the burgeoning industry that no one really expected 20 years ago?
It's coming, whether you like it or not.
We've always done some sort of automation. We've looked at it. I mean, we're even starting to look now at not so much the control of it, but how artificial intelligence as well, because that's a different subject than automation, but it's how we're going to use that going forward. So that, you know, within our discussion groups, we're talking about using it for planned maintenance schedules and fault reports and stuff like that, how that can help you delve down and make that a better platform. So it's definitely coming. It's definitely being used already. You know, I know from our committees.
Well,
yeah,
what,
and I think
sorry.
The other level here is that wharf mission equipment will become autonomous. So you won't be taking people off vessels overnight, but what you get is a lot more autonomy creeping into all the systems, you know, reducing the amount of people on board. And then you've got the environmental impact of reducing people, having a more efficient vessel, burning less fuel, less emissions. So there's that. The entry into the industry, it's suddenly opened up to a lot of people because everybody in the merchant navy had to pass a medical, you know, offshore medicals. All of a sudden, maybe you don't need that. And
Yeah.
there's especially from the female perspective, where women working at sea, you know, they want to start families. They go ashore to start a family. Often they don't return, so you lose that vital skill at sea. But maybe not the case anymore. That person can then go into a ROC and still keep the same career progression, and all that training isn't wasted. So there's so many factors at play here. It's not just what we've just been talking about today. There's lots of periphery going on, and I think it's quite exciting that we're moving in this direction.
And all of our guidance as well, we're starting to include, you know, remote operations within those as well. So we're writing them into them guidance as it appears. You know, we're trying to be as ahead of the curve as much as possible. We've even introduced a remote pilot qualification now. So previously it started at the introductory level, then went to ROV Pilot 2, 1, and vice versa. So now there's a remote pilot one, because ultimately these people are not going to be actually seeing the ROV, so they don't need mechanical, electrical, or electronic or fiber optic qualifications. They can be coming straight from university. They've been very, very good at simulating systems. So all they need to do is do the training side of it on life offshore and all the risk and the safety around it. And once they understand that, then they can come in, and they'll more than likely as well be working like 3 shifts. So rather than doing the 12 hours offshore, they'll be doing an 8-hour office day, and there'll be three of them split out. That's the way we expect it to work going forward. It'll be a clean environment. They'll always have the specialists, the ones with the experience who have been out there doing it behind you. They will be the supervisors that are watching everything, and they can jump in whenever they need to. But we see that as what it's going to be going forward, yeah.
Well, and just in time, because we do have a chronic lack of people coming into the industry, don't we? So,
yeah.
And with people retiring at the other end.
In multiple disciplines as well, geophysical, geotechnical, yeah. It's
not only that, it will save money. I mean, they've got to look at the bottom line in wages and all of that. But yeah. I suppose there will be other costs in paying for the inspections and getting that all online as well.
Yes, we're trying to keep that as minimal as possible, you know, going forward, especially to start with. There's a massive ROV fleet out there. So, you know, we're not classing an ROV the same as a vessel. You know, when the actual system comes online in the EC mid system, it will be a very low cost. So, you know, companies that have got, like, you know, 250 ROVs are not going to be suddenly hit with, you know, the clients wanting every single system inspected before it goes anywhere. You know, ultimately it'll be their system, they'll control that, and it'll be a very, very small fee, you know, for those, because it's a, you know, a smaller class of inspection.
Yeah. Right, well, I think that's it for the questions in the chat room. A lot of people often want to go back to questions afterwards. So to everyone listening, please do feel free to contact Richard or Roger or Imka, or indeed us at Seawork, and we'll field questions or direct them to the right people. Leaves me just to say thank you very much for your presentations, both of you, to everyone who's joined the webinar. It will be up on the Seawork website soon if you want to go back to it. And of course, there will be more to come in Seawork in June, Southampton 9th to the 11th at the Mayflower Park, where Richard and Roger will both be. So leaves me just to say thank you and goodbye.